All right, it is recording. Okay. All right, let me start. So today we're gonna talk about the last chapter. Okay, your product development process, the very last chapter in the lecture sessions, in the textbook sessions. Okay, so we covered this chapter, and then we're gonna move exam and also the simulations. So we focus on your entrepreneur simulations. You are already familiar with the simulations. Okay? You did 2 practice rounds. Okay? So I'm not worried about at this point. Okay? But if you have any concern about the simulations, you always, just contact with me. Okay? The email is always open. Okay? All right, so let's talk about new product development process. Just take it away from my table. Okay. All right. Very simple topics. Okay. Actually, you already knew this process because we talked about the dimensions of innovation management in the previous chapters. Okay. All right, so I just want to make sure everyone is ready to go. So if you don't have connection issues or you don't have any issues, just let me know. Just type yes. Okay, great. Thank you so much. All right, let's go. Okay. And I just want to make sure our schedule, this schedule is exactly consistent with the schedule on the syllabus. Okay, so today we're going to talk about chapter 11, product development process. Okay, and then the exam 3. Okay, the last exam. Okay, the next, this Thursday. Okay, and the next week, Tuesday, we're going to have presentation 3. Okay, your presentation will be focused on your simulation. Okay. The 2 practice rounds, what you did, how was the simulation, how the performance was, okay, and what you want to do. All right, something like that. Very general ideas of your simulations. Okay, and then you will do simulation round 1 at the same day. All right, Tuesday. And I already informed about the schedule change. Our very last presentation 4, was scheduled on December 2nd, but it's moved to November 18th, Thursday, because I wanted to have a chance to talk about harvest strategy in your simulations. Okay. All right, let's move. This is distribution of your owner keys. Okay. Nice. Unbelievable. Average is a 6.89 out of 7. Almost perfect scores for everyone. Okay. And standard deviation is 0.31. It's nice. I don't have any other comments on this. I'm just, totally happy. So let's take one quiz. Today I'm gonna a little bit speedy because this is the last test you are familiar with. Okay. So please go ahead on a canvas. Okay. And then you can find chapter 11 one keys. Chapter 11 one keys. And I'm going to give it 10 minutes. 10 minutes. Okay. When you're done, please let me know. Just type done. Okay. I'm going to mute my microphone. Okay. Actually, many students are doing fast. So anybody needs more time? Just let me know if you need more time. Okay. So if you're not done yet, just keep doing, okay? So let's talk about the product development process, okay? Simple topics. We're gonna talk about some types of product development process and some techniques for the effective product development process. That's it. Okay? That's it. So today I will be a little bit speedy. Okay. So number one, a majority of new product development projects results in an economic return. No. We talked about that. Raw ideas, idea funnel. Okay. The funnel of raw ideas. Okay. Only one idea out of 100 raw ideas will be commercialized. Same thing. New product development. Okay. A very small number of new initiative, okay, tries can be commercialized. Okay. So this is first. Number two, a sequential process. Okay. Two types of what? Product development process. Sequential and partial parallel process. Simply speaking, sequential is just one way. Okay. So one way. Only one lane. Okay. So if you've done A, you do B, and you do C, D, something like that. But parallel sequential process. Okay. Partly parallel process is, you can do multiple jobs at the same time. You do A, some part of B, something like that. Then you will next process. Okay. All right. A sequential process has an early warning system. No, it's a sequential, one lane, one line. Okay. So no early warning system. At the very end of the process, you find this is, technically, impossible, then whole process just, stopped. Okay. All right. Number three, the use of executive sponsors. Okay. Executive sponsors reduce the effectiveness of the development process. Actually, it's the opposite. Okay. The executive sponsors are very important to improve the effectiveness of process. Okay. Enhance, actually, not reduce. Number four, firms often make decisions about projects on the basis of marketing criteria. This is this causes many problems in Japan, in German industries. Okay? Actually, it is much better. Okay? Firms stay with the marketing criteria, but many companies actually they make decisions based on some engineering criteria. So their engineering skills, engineering techniques are great, but customers do not appreciate it. Okay? It's a problem. So highly developed, advanced engineering nations, something like Japan, okay, then their products are not consistent with the requirements of customers. Okay, it's a problem. Then you need to think about this point. You need to think about this point in your simulation too. In your simulation provide a lot of information, and also this information includes the information about your customers, what your customers are really like. Okay. Your simulation provides that information. You need to find it. Then your product should be consistent with this. Okay. what your customers like. All right? Do not forget about this. This is very, very important. Okay? Number 5, suppliers can contribute ideas for product improvements or increase development efficiency. Yes, yes. Actually, anybody, suppliers, customers, any stakeholders can contribute, okay, in the product development process. Number 6, the criteria in the go-kill decision points are the questions or metrics used to make decisions regarding whether or not to kill the project or allow it to proceed. Yes, this is the definition of go-kill decision points. Okay? Number 7, using computer-aided design, CAD. You're not engineering students, but you should know CAD. CAD is wonderful, wonderful program. Okay? So in the company, there is ERP programs, something like SAP, okay? SAP, entire resource, ERP, entire resource program. So something like SAP, probably you, in your future job, you will have a chance to work with SAP. And also in the engineering part, CAD is mostly important program. Okay? Actually, I use this CAD-based program to design my basement. I designed my basement, and then I did some, any permission or whatever administrator works. Okay, so I was the something like a design, architectural design. Then I just hire a what is that? Just managers, not men, contractors in partly. Then I complete my basement. Okay. Okay, so this CAD is, the important program in the engineering field. So using computer-aided design CAD to build and test product design increases cycle time, no, decreases. Okay, this is a wonderful, wonderful program. Okay, so easy, huh? Okay, actually we talked about most topics, okay, that should be discussed in this chapter. Okay. All right, any question, comment? Okay, let's move. All right, we're here, chapter 11. All right, new product development process. So we talked about some strategic management criteria of innovation management: reduce cost, increase product differentiations. Then we have competitive advantage. Okay, so how to manage the product development process is the last part. Okay. All right, today's class activity. So the last case, all right, in this semester. Frog. Very interesting case. So I believe you already did this case. So I want you to discuss only 3 questions. Okay, not all questions. All the questions, not all the questions. The first one, second, and that's the first one. So we want to briefly talk about, after your discussions, we want to briefly talk about these 3 questions. Then we'll move. Okay? So let me make your discussion rooms. I'm going to give you 10 minutes. Okay, please join with your team and discuss about your case. Okay, then be ready to briefly answer these 3 questions. Then we can go speedy, a little bit speedy. Okay, please go ahead.
You are currently the only person in this conference.
All right, welcome back. Welcome back. So I believe your discussions were good. Okay. All right, so let's talk about this case. Very simple case, but it has many implications about product development process. Okay, effective product development process. All right, the first question: how do Frog's activities affect its ability to maximize the fit with customer needs? Very important. Minimize development cycle time, reduce cost, and control development cost, reduce cost. See? Two generic strategies: increase product differentiation, maximize the fit with customer needs, and reduce cost. Two other things. Okay, so how do Frog's activities affect these things? Okay, maximize the fit and minimize cost. Okay, anyone can start. Please go ahead. What did you discuss? Yeah, turn on your microphone and say something.
One of the things that our group discussed was their low resolution models kind of provided just a brainstorming platform for their clients. And so because they were low resolution and not super detailed, it allowed them to decrease the cycle time, maximize input and creativity, and also prevented them from sinking a lot of costs into a detailed model that ultimately would need to be scrapped.
All right, great, Emily. Thank you so much. Okay, so reduce cost. Okay, low resolution. Okay, not great details. Okay? Then it minimized development cycle time, and it reduced cost too. So in the cost side, okay, it's great. Okay, any other idea? Anything else? Any other team?
We said that like the constructive feedback that the firm gave the client was very helpful in helping them like decide which design they want to go with.
It's great. Thank you, Noah. Thank you, Noah. It's a great comment. Okay, so maximize the fit with customer needs because customers provide feedbacks. So Frog actually has some mechanisms to observe okay, the customer's needs and also to reduce cycle time and the cost. Great. So your discussions were great. Emily, Noah, thank you so much. Okay, let's move to the second question. What are the advantages and disadvantages of involving customers fairly deeply in the design process? Noah a little bit mentioned about this. Anybody has more ideas about this? Customers involvement?
One of the things that we discussed was basically by bringing in the customers, since the customers are experts in their area, they're going to have a lot more information than you as an outsider have. And so they may be aware of problems that you don't even know you're trying to solve that they can bring to your attention.
All right, great. Customers provide a lot of information. All right. A lot of good features of product. Okay. So it is usually customers. Okay. Customers can be an innovation source. We talked about that, the source of innovations in the earlier chapters. Okay. So that's why we care about customers because they are source of innovations. Okay. Thank you, Emily. Nice. Any other ideas? What are disadvantages? Probably. Okay, Molly, go ahead.
Oh, I was just going to say that we talked a little bit about that customers may have like pretty strong opinions on there. And if you listen to it maybe a bit too much, you might get away from your original idea or product design, so that it becomes something completely new, and that might not be what your company wants to do.
All right, it is the Molly's point. Okay? Your discussion was consistent with my perspective too. Actually, customers, they exactly know what they want, but sometimes they don't understand the engineering part, technology things. Okay, so they do not have any idea which one is possible, which one is not possible. Okay, so they produce a lot of desires, but sometimes it's feasible, sometimes it's not feasible. Okay, all right, any other idea about the second question? Okay, then move to the last one. Would Frog's approach be more suitable for some kinds of development projects than others? If so, what kinds would it be appropriate or inappropriate for? So your ideas, any idea? The last question. What Jesse, go ahead.
So I talked about like how it would be more effective for the firm to like include all the departments, as they could like understand the product better, and also they already have like the staffing and knowledge to be able to run all aspects of the frog approach. I'm not sure. Me and my group, we didn't really get too deep into that, but so I don't know if that answers it, but that's kind of what I wrote down.
Oh yeah. So it is very important that, if the project should be understood by entire organizations, entire departments, then probably Frog's approach will be perfect. Okay. So, some designs, some products, developments, okay, it should be involved with a lot of departments. Then, okay, entire organizations should understand this process. Then, Frog's approach is perfect. Okay. So, from this point, I was thinking about sequential versus partly parallel development process. Okay, I talked about that. Sequential is just one line. Okay, one line, A, B, C, D, sequentially. But parallel development process is sometimes overlapped. A, B can go at the same time. Okay, so then Frog's approach is good if entire organizations involved with this process and they enoughly understand this process, then they can set up some partly parallel development process easily, so they can reduce cost. Also, they can increase productive pronunciations. Okay, so that was my impression. Okay, all right, thank you, Jesse. Any other idea about the last question? Any other comment? All right. So great discussions. All right, nice discussions. So it seems that you enough. You already understand this. A lot of implication from this case. So no question, no comments. Please say yes if I can move. Thank you, Noah. You're so fast. All right, let's move. So,
it's looking good.
Malik, can I mute your microphone? Okay. All right. Malik, do you have any comment? Probably not. So it says that accidentally, your microphone is on. All right, so we already talked about some parts of the topic. Okay. Failure rates are still very high in the product development process. Okay. So the idea funnel, we talked about that, right? Only 1%, 1 out of 100 ideas will be commercialized. Same thing. Okay. And more than 95% of new product development projects fail. Okay. So in your future job, your ideas, your project is failed. Then what? Just disappointing and do nothing? No way. Okay. So it is so natural. Your project is failed. But you learn something, you just focus on the next project. Okay. Then you will hit home run. Okay. And let's move. Okay. So sequential versus partly parallel development process. This is a sequential and this is partly parallel development process. So overlap at the same time, these two jobs done. Okay? These are partly parallel process. And this shortens the cycle time. Look at this, and this. Okay. So we talked about in the earlier chapters Gantt chart. Actually, many people use Gantt chart using Excel, okay? Something like this. Okay. All right. So Gantt charts and sequential versus partly parallel development process. Okay. All right. Let's move. And then project champions. Senior executives to champion their product development projects. Okay. So senior executives have a strong drive. Okay. All right. Because it reduces a cycle time. All right. It sometimes becomes the technique to have effective product development process. The benefits of championing, this is something like a commander in the Marines. You do this, I will do this, then everyone do this, something like that. Senior executives have power to fight for project. They can gain access to resources. They can communicate. Okay, it's perfect. But the risk of championing too. Role as a champion may good judgment about project, may suffer from escalating commitment. Others may feel challenging senior executives. Okay, nobody wants to talk about it. Any criticize, no criticism, something like that. All right, so championing and also anti-champions encourages expression of dissenting opinion. Okay, so you can use way of balance. Okay. Involving customers, we talked about this already. Okay, very, very important. Customer is the source of innovations. Okay, all right. So, again, your simulations. Okay, so when you think about your product, okay, where it should be located, then you should know what your customers are thinking about, what your customers want. Okay? In the presentations too, your audience want what they want. You should know it. Then you have a good presentation. And also in the simulations, okay, you should know what customers like. Then you have a good presence. Okay, so in your simulation, you should find some information about the customers. Okay, involving suppliers too. Suppliers is a source of innovation too. Okay, all right. And suppliers can suggest alternative inputs that reduce cost or improve functionality. Okay, and this is a stage gate process. So stage gate means you do first stage, then the second stage, say yes, 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 and you go forward. If say no, no. Utilize tough, go and kill decision points in the development process. Filter out bad projects. Why we are worried about bad projects? Because it's a high chance, at least 95%. Okay, a lot of cost. All right, the time and cost projects escalates with each stage. Okay. Look at this. Okay. Thus, a stage gate process only permit a project to proceed if all assessment indicate success. Okay. So think about that. If you fail, okay, in somewhere here, then the cost, oof. Think about that. Biopharmaceutical industry. IT industry is much better because R&D cost, R&D cycle time is short. R&D cost is relatively smaller compared with that of biotechnology, biopharmaceutical firms. Biopharmaceutical firms, okay, they develop, and fail this testing and validations, something like FDA process. It becomes nothing. You waste almost 1 billion. That's total disaster. So that's why biopharmaceutical firms use this a lot, stage gate process. Okay. All right, the stage gate process can be modified to better fit a firm's particular development needs. Okay. So when you think about this stage gate process, you need to think about the biopharmaceutical industry rather than IT industry. Okay. All right, quality function deployment, the house of quality. So these are each engineering, components. This is customer requirements. So in this engineering component, okay, easy to open is a customer's perspective. So combination of engineering attributes and customer requirements. Okay. Easy, huh? And these are correlations. Okay. Correlation between technical specification. Okay. All right. So the house of quality. Okay. So this is one very simple technique, okay, to use to have effective product development process. Who judge this? These numbers. Who judge this? You will do. You do. Okay. You are businessmen. You are managers. Okay. You become decision makers. So who will do? You do. Okay. Sometimes you can use the information from the customers, suppliers, and other stakeholders, but actually the final decision makers, you. Okay. All right, then steps for QFD. Okay, you just read it, then you can understand this. Okay. Design for manufacturing often involves a set of design rules that reduce cost and development time while boosting quality. Okay. Okay. Very interesting. Design rule. Minimize the number of parts and, so IKEA, think about that. IKEA furnitures. Okay. They use this a lot because IKEA is basically a design company. Right? The design for manufacturing. Minimize the number of parts, eliminate adjustments, eliminate fasteners, and eliminate jigs and fixtures, something like this. Okay. So then you can understand it. Value modes, effect analysis. Oh, probably I have an example. Not. Okay. So FMEA, failure modes and effect analysis. FMEA is the method by which firms identify potential failures in a system, classify them according to their severity, and create a plan to prevent them. Okay? So basically, you need to think about the potential failures. Okay. Then in the process, then you try to prevent them. Okay. And use numbers. Each criteria is given a score. 1 is smallest and 5 is greatest. Okay. All right. It's very similar with the house of quality. Okay. And CAD CAM actually. CAD is the use of computers to build and test designs. Okay. This is wonderful. Okay. I didn't have any background of architecture, but I did the design of my basement with this CAD CAM actually. CAD CAM. Okay. So what was wonderful? Then I just lay out all the rooms and some fixtures and something like bath and sink, something like that. Okay, and then I just characterize each the space in my basement. Then I put something. It's something like the game. Like there are a lot of menus, and then you can just click it and drag it down, something like that. Then if I make something stupid decision, then actually this program asks, "Are you sure?" Something like this. Okay. So it's my mistake. Then it helps a lot. Okay. And I just played as a role of general manager. It was easy. So if you have any chance, you don't need to be an engineer of CAD/CAM, okay? But if you are familiar with what this program is, CAD/CAM, okay, it will be great. And also 3D printing, 3D printing, okay? You're familiar with that, right? Hackberry, and we have some the facilities for 3D printing. Okay, so many students are exposed to do with this technology, 3D printing. Okay, all right. And performance. Okay, performance. New product development process metrics. Okay. These are to measure performance, cycle time, okay. What percentage of development projects met most of the deadlines and stayed within budget and completed. So you can ask next questions. Okay. Then okay, you can score. Out of 10, 10 is highest, 1 is lowest. Then you can evaluate. The current projects. So, process metrics. This is a performance tool to measure your performance, the project performance. All right, that's pretty much about. Overall innovation performance is almost the same thing. You can just read, you can understand that. Okay. All right. I'm done. This is pretty much about your last chapter in the textbook sessions. So for me, I am ready to move forward. Okay. The simulations. Okay. Any question, comments? Any question, concern, comments about the lecture sessions, textbook sessions? Okay. If you do not have, please say no. All right, great. Okay, I believe so. Yeah, I believe so. So your understanding level, actually conceptual understanding level is really high. Okay, I believe so. And this time you conceptually understand the innovation management, and then we will have a chance to practice your conceptual knowledge into the practice using simulations. That's why we focus on the simulations in the next few times. Okay, so I am happy with this progress. Okay, so you are doing great. All right, so if you don't have any question, comment, on Thursday we're gonna do exam 3. All right, exam 3. So I'm not worried about the exam. It's a very similar format, okay, from the previous ones. Okay, so exam 3, we just take it away. Then we're gonna focus on simulation in the next week. Okay. So if you don't have any other comment or question, I will see you on Thursday. You did a great job today. Thank you, Molly. Thank you, Courtney. All right, see you Thursday, Courtney. Emily, thank you. Noah, thank you. Jesse, okay, great. Noah, thank you so much. I will see you on Thursday, okay? All right.